Do we all have a copy down? Yes, I know it was in the videos, but please copy down again. Discrete and continuous. Discrete is a graph that is made up of distinct, unconnected points. Just like this. You just see points written on there. Continuous, a graph that is made up of connected lines or curves, just like this here. Continuous does not mean it has to go on forever. It just means whatever is in the picture, it is all connected. Please copy this down. For each of the following examples, we're going to do 3 parts to them. State if the relation is a function, state if it is discrete or continuous, then state the domain and range. Let me know when we have it all done and we'll move on. Do we all have up to here copied done at least? And please draw number 1. Part A, is it a function? Yes or no?
No. No.
You say no, why not?
Because it fails the vertical line test.
Good. It fails the vertical line test. We can just write VLT. You do need to have an explanation because on the test it will say, is it a function, why or why not? Yeah.
So you can just put it just failed the VLT in that computer.
Yeah, well, if it gives you a graph. If it doesn't, such as ordered pairs, you would say no because the x value repeats. Or you can graph them and say the VLT failed. Part B, is it discrete or continuous? It is discrete. Now my domain. My domain is which values? X. Are my smaller x on the left or the right?
Left.
The left, because they're negative. So let's start. What's my x value for this point here?
Negative 2.
Negative 2. So I just need the x. How about for this one here?
0.
And the x for these two here?
2.
2. Now the range is what values?
1.
The y. Are the smaller y's on the top or the bottom?
Bottom.
The bottom. What's the y value for this point here?
Negative
The next one?
1. I mean 0.
0. This one up here?
1.
And the last one? 2. Is there anything difficult about number 1? No, very straightforward, correct?
Yes.
The next example will not be as straightforward. The next example looks like this. Go to copy that before I get started. Let's start with A. Is it a function? Yes. Why?
Passes the vertical line.
Good. Yes, it passes the vertical line test. Part B, continuous or discrete? Continuous is just one continuous line. Now part C, the part that gets confusing. Let's start with the domain. The domain is my what values? X. So we start to the far left, but what do these arrows here mean?
Oh, it goes from.
It goes on forever. So in reality, if this line kept going forever, it'd keep going this way, this way, this way, it keeps going forever and ever and ever and ever, and wouldn't stop. Do we know what my smallest x value is?
0.
What is it?
It is negative 1.
But no, it keeps going though. Will it ever stop?
Yeah.
It will never stop. So what does it become? Negative
Oh, point?
infinity. Negative infinity. Because it will go on forever. Yeah. So this direction here. Pencil.
Wait, so would it be like.
Because remember, the domain is my x's, correct?
Yeah.
So this line will go on forever, which means in this direction, it'll keep going to a negative infinity.
Oh. That's positive infinity.
So the right side, correct? Going this way here will go on forever, which means this will go to positive infinity.
Does it infinitely many solutions?
No, because you're not really dealing with solutions. Let me show you how I want it written. There's two ways. We talk about inequalities as being a range of numbers, correct? If it's greater than 4, it's all numbers from 4 and above. It's that whole range of numbers. That's what we're going to do the domain as an inequality. The domain, actually, I'm going to do it under. It's everything from negative infinity. What kind of values am I looking at? My x or my y? X. So all those numbers from x that are in between negative infinity and positive infinity. Why did I use infinity? What told me I'm using infinity? The
arrow.
arrows. So we can actually add that as a little note somewhere on the paper. If you have arrows, use infinity. Do we understand the domain? Somewhat. Alright, the range now. The range is my what values? The y. Actually, before we go to the range, on the domain, the other way of writing this, if you have negative infinity and positive infinity, the other way to write it is by saying all real numbers. Okay, saying my x values are all real numbers. It could be any negative, it could be any positive number.
So that goes for the
Yeah, so if you have both negative and positive infinity, then you can just write all real numbers. Either way I'm okay with. But now for the range, it's my y values. How far up does it go? How far up?
Infinity.
Infinity, because it will never stop. Is there an arrow pointing down?
No.
So will it go to negative infinity? No, what is the smallest number it goes to?
-3.
Negative 3. So my range is from negative 3. What letter am I using now? It's my y is good. All the way to what? Infinity. Can I use all real numbers now? No, because all real numbers includes negative 5, which isn't included in this picture. So my range is only from negative 3 to infinity. Do we kind of start understanding this? Anybody need me to explain anything else? Alright. This will take some time getting used to, but here's the reason we need this. The reason it's a whole inequality here, because it's telling me everything from negative 3 to infinity is acceptable. Think about if we had this word problem of filling up a bathtub. How long did it take to fill it up? Does the water all of a sudden fill up from 0 minutes to 15 minutes? It just automatically fills up at 15 minutes? No. It continuously fills up, little by little. Correct? That's why we have to have this. Because it isn't like at 0 minutes is 0 water, and at 15 minutes, boom, it's filled up. It's continuously filling up from 0 to 15 minutes. All the way, it just fills up until it's done. Does that kind of help make sense of why we need continuous? Let's go to example 3. Let's go to example 3. Now I want you guys to try this on your own. It's just like example 1. Yeah, please. Please draw the picture. It'll help you when you go back to look at your notes. Give it another 30 seconds. Alright, part A. Who is the answer? Go ahead. Is it a function? You say no, why not? Where at? Remember, which way is vertical? Up and down or left and right? Up and down. So we only care about this. Can a straight line pass through more than one point at a time? So we can check it with this. How many points does it touch? One. Here, how many points does it touch? One. Here? One, and here. Is it a function? Yes, good. Yes, it passes vertical line test. Part B, discrete or continuous. Who's the answer? Go ahead. Is it continuous? Is there one line that connects to all those points? No, which makes it discrete. Because it's points, it breaks up, it's broken. It's not just one line that goes forever, it's broken. Domain are my what values? X, go ahead.
-4, -2, 0, 1.
-4, -2, 0, and 1. Good job. And now my range. Someone else, who's the range? Go ahead.
-1, 0,
-1, 0, and 2. Guys, I did this on purpose. I added 2 -1s on the y. Do the y values matter? No, it's the x that matter to make a function. Do you have any questions on example 3? Now one of these for you guys to try. Where we have trouble with it. Are there any arrows? No. You only use infinity when you have arrows. Since you don't, you will not use infinity. I want you to try it even if you're stuck. It's alright to get it wrong as long as we're trying it now. Your first attempt at these should not be on the test. Should be right now when someone's here to help. So let's start. Who has the answer to part A? Go ahead, Danielle. Why is it not a function? What does it fail? So I can kind of draw a line here. I can see it touches 2 spots. So we can say no, it fails. Whoa. The VLT. Who has B? Julian. It is continuous. Because everything in the picture is connected. Everything in the picture is connected, so it's continuous. Part C, my domain. What do you have?
0, -4, -2, and -3.
So he says this. 0, -1, -2, -3. That's what he said, but what about this point right here in the middle of 0 and -1? What about all those little points in the middle of -2, -3? Do those all count? Yeah, right? So you're not the only one that's done this answer. That's why several people do it. When it's continuous, we have to use inequalities because it contains everything between here and here. Because each little speck along the way has a point, has something on it. So in reality, my domain will be everything from what's my smallest x? -3 to what's my biggest x? 0. So it's not infinity because there's no arrows, but we still have to write it like this because it's continuous. You can make a note for yourself right now. If it's continuous, I must have inequalities in it. Yeah.
Will those less than or equal to signs ever have to change?
They're always going to be facing the same way, like this. Kind of makes it easier.
So will it be the same thing for range too?
Just different numbers, but yeah. So the range, who has an answer for that one? Go ahead, Adrian.
From -3 to less than or equal to
Okay, so -3 is less than or equal to
y,
y.
less than or equal to 3.
Good. He's saying it's all the values from -3 in the y to +3 in the y. Because every little speck along the way is being filled up. Do you have any questions? Do we understand this a little better now? Alright, the last thing I need to cover for your homework. It says, find the range given the following domain of 0, 1, 2, and 3. So we're using that domain to find the range for the next two problems. Here's example 1. So it's saying my domain, well, let's say this. My domain is my what values? X. What other term have they used for domain? They used something else. Was it the input or the output? Input. So when I plug in these numbers, I'm going to find my range, which is my y or my output. So here's how it'll look. For the first one, it says y equals 3 times 0, because my first one, minus 5. What's 3 times 0? Minus 5? Negative 5. We're going to do that for each one. What's 3 times 1? What's 3 minus 5? What's 3 times 2? 6 minus 5? 1. And what's 3 times 3? 9. What is 9 minus 5?
4.
So my range, we still want to write it in coordinate or in the set notation. My range is -5, -2, 1, 4. Do you have any questions? We're capable of doing this ourselves. Here's example 6 for you to do on your own, and that's the last one. You're using the same ones as above. You're still using 0, 1, 2, and 3. What's my answer? 0, 1, 4, and 9. Remember, squared means that number times itself. So my range is 0, 1, 4, and 9. But pass out the homework, cover what has to be done for it, and then you're on your own. The JV students they lost theirs today.
What school is it?
Corner. Alright. This side here. Numbers 1, 2, and 3 state the domain and range. What's the domain for number 1?
No, -1.
Whoa. We're on the wrong
Negative.
side. We're on the wrong side.
4, 8, 12,
4, 8, 12, 16. Is that one of my answer choices on the bottom? What letters? T-O. I'm going to cross it out. Number 4. Number 4 really has 2 questions in it. It says we're plugging in 3 and we're plugging in -5. If I plug in 3, I get 4 times 3 minus 7. What's 4 times 3? 12 minus 7? 5. Is 5 one of my answers? And me, right? Cross it out. 8 through 13. Same thing we just finished the notes with. We're plugging in all 3 of these points that it gives you. The hardest one will be this one here. Solve for the top first, then solve for the bottom, then divide with the top from the bottom. Good? Turn it over, please. It says, figure out if each one is a function. The way you cross out or circle is going to determine your answer. Is number 1 a function? Yes, the x's do not repeat. So under 1 on the bottom, I'm going to circle the letter that says is a function. Now we go to number 2.
No.
No, why not? 2 negative 2's. So under number 2, I'm going to circle the one that says not a function. You have any questions? That's your homework. Both sides. Get it done.